Hello and welcome. My name is Paul, and today I'm going to talk to you a little bit about tracing memory allocations using the XDBG debugger, and also explain a little bit about the differences and relationships between three APIs: VirtualAlloc versus VirtualAllocEx versus NtAllocateVirtualMemory. This diagram here shows a very good relationship between the three APIs. At the top is the VirtualAlloc API, and then VirtualAlloc API sometimes is recognizable as VirtualAllocEx, which is also similar to VirtualAlloc, and they both refer to the user mode APIs. They both belong to the user mode APIs. Ultimately, all of them lead to the kernel mode API called NtAllocateVirtualMemory. When you are trying to trace the base address which is being allocated by these three APIs, you need to look at different parameters. So for example, let's take the first one, VirtualAlloc. Head over to your MSDN reference for VirtualAlloc, and you will see that this explanation of the various parameters. The important thing is the return value for VirtualAlloc. If you scroll down, you will see VirtualAlloc returns value. If the function succeeds, the return value is the base address of the allocated region of memory. So if you are using an XDBG debugger, you should look for the register EX. Function calls always return the values in EX. So VirtualAlloc will return the base address of the allocated memory region in the EAX register. The same thing holds true for VirtualAllocEx. If you look up the VirtualAllocEx MSDN reference, and if you scroll down to the return value, you will see that if the function succeeds, the return value is the base address of the allocated region. So again, if you want to look for the base address being allocated via this API, then look in the EAX register and you will see the base address being allocated. Now let's look at the third one, the kernel API, NtAllocateVirtualMemory. This one is different. This one does not return the base address in the EAX register. Instead, it returns it in the second parameter of this API. So the second parameter is explained here. Base address, a pointer to a variable that will receive the base address of the allocated region of pages. And then what does this API return? If you scroll down, you look at the return. NtAllocateVirtualMemory returns either status success or an error status below. And status success, if you look up the NTSTATUS value, means all zeros. That's the meaning of status success. So now enough of theory. Let's open up our XDBG and try to look at some practical applications, how we can make use of this knowledge. So when you are trying to do this, always use a virtual machine. So in this example here, this is a malware sample bin, and I'm going to analyze this memory allocation by this malware. So I'm going to run my x32dbg as administrator, and then the settings, I'm using December 22, 2021's version of XDBG, and I'm running Windows 10 virtual machine. My options are as follows. Under Options Preferences, I set only entry breakpoint checked. So now let's open our malware sample bin. Since it's a bin extension, we will select all files. Click on bin, click open, and now it will hit our breakpoint. So now if you want to put a breakpoint on the APIs, we use the breakpoint command. You can set a breakpoint down here. So I happen to know that this malware has got anti-debugger capability. So we have to defeat the anti-debugger. To do that, we must first put a breakpoint on isDebugger protect, isDebugger present. So type BP isDebugger present. Hit enter, and you will see the breakpoint is set. If you go back to the breakpoint tab, you will see that the breakpoint has been set to isDebugger present. Alright, so now how do we defeat the anti-debug? Just run. Click on run. And now it has hit the API isDebugger present. So now we are going to run to user code. Click on this so that we will let it execute. We are now in the system space. As you can see, kernel32.dll is where this API is found. So we want to execute this until it goes back to the user module, the user space. So we hit this button here, run to user code. So it has already executed the isDebugger present, and now we'll come back to the user space. As you can see up here, sample bin, and we are in the user space. Now if we go up one step, you will see that we have just came back from this function, this function call, and the result of this function call is in the EX register, and it shows 1, which means that it has already detected that a debugger is present, which is the XDBG debugger. So how do we defeat that? To defeat that, we can just right click on this and then modify value and set it to 0. Hit OK. So we are now modifying the result of this API call to set it to false. By setting it to 0, it means false. That means debugger is not detected. And you can see now the next test here is to test whether this value is 0 or not. So if you step over now, you will see that the test has failed. That means it is 0. So that means debugger is not detected, and therefore this JNE, which means jump not 0, will not occur. It will go straight. We have successfully defeated the anti-debugger detection by this malware. Now the next thing you want to do is to detect the VirtualAlloc memory allocation. So to do that, we come back to the command here and put a breakpoint on VirtualAlloc. Then hit enter, and you see it says breakpoint set. So to confirm that, go back up to the breakpoints tab, and you will see that the VirtualAlloc breakpoint has been set. Now go back to the CPU tab and click run until it hits the VirtualAlloc breakpoint. So click on run. And now it has hit our VirtualAlloc. So we step over it. Until we come to this function called NtAllocateVirtualMemory. And then if you look over here, the second parameter is your referring to this. Second parameter is the base address, where you will find the allocated region of memory. So this second parameter is coming from here. So the parameters to a function call are pushed in reverse order from bottom to the top. So push from bottom to the top. So all this eventually will be residing on the stack in readiness for this function call. So that's why this is the second parameter we should be watching out for. You can right click on the second parameter and follow in dump, and this will be your address of your allocated region of memory after this function runs. So let's step over this to run the function. And now it has called this function, and if you look at the return value is 0. So the return value according to the MSTN reference tells you, if you scroll down and look at the return value, if the function succeeds, it returns status success. And as we have seen earlier, status success means hex 0. So if you see hex 0 here, it means that this function call was successful. And the second, this is the address which has been allocated. This is in little endian, so it reads as 012E. 012E followed by 4 zeros in Intel little endian order. So you can actually go there now, this region of memory, 012E followed by 4 zeros, go to memory map, 012E followed by 4 zeros, and if you scroll to the right, you see it's private, meaning that it has been allocated using VirtualAlloc functions. And then the permission protection is ERW, which means executable, readable, and writable. So this confirms that the memory has successfully been allocated. So this is how you can use knowledge of these API calls to trace memory allocations. And in this video, I explained to you the 3 types, and we are looking at the 3rd one now. So thank you for watching. I hope this helps out you guys. Bye for now.